Okay, Assalamualaikum warahmatullahi wabarakatuh. So, it's 2:02. I think we should start. So before we start, there are a few announcements. With, so a reminder, midterm exam will be on esok lah kan. Midterm exam esok. Starting at what time?
5 sampai 7.30.
5 sampai 7. So you're yourself available for that. On the final exam, just the basic exam. So make sure that you watch out on the Facebook and also communication with UTEM. There'll be a mock exam so that you can log into the final exam system to try it out. So please do that. Make sure that you familiarize yourself with this. That's one. Second, make sure you activate and make sure that you know how to you are able and also know how to access your email. Make sure your email account is active. This is talking about the official UTEM email account because you need to use that for the final exam, access to the final exam. Okay. If you got problem, these are some of the message that I got and I jot down during the briefing just now. If you have a problem with the portal of final exam, make sure that you refresh the window several times. Okay. And you are required to be available to be contacted by me or by others from UTEM 30 minutes after the end of the final exam. So make sure that 30 minutes after the end of the final exam, you are available and you can be contacted through for you guys. If I want to contact you guys, I'll do it in two ways. Once using your official UTEM email or using WhatsApp. Right? That's to make sure that if we have any issue or any questions with regards to the file that you upload for the final exam, we can contact you. Make sure that you're available 30 minutes after the final exam. Another items that I think you should be aware during final exam, you're going to upload the answer script, and the maximum file size for the answer script is 10 megabyte, 10 MB. So I think the best bet is a PDF. Should be less than 10 megabyte. And make sure that that you remember that for the final exam answer script, you have to sign every single page. Every single page of the answer script need to be signed. So these are some of the items that I think is quite important for you to remember for the final exam. Again, there'll be a mock exam for you guys to use the system. So make sure you try that. And I think it's going to be available sometimes next week or during the semester break, during the study break. Okay. So those are the items that being downloaded, and this system is quite new system. So I strongly advise you to try it out during the mock exam period. Okay. So any questions with regards to that or with regards to the exams, the midterm? Okay. So the other thing that I want to remind you guys, assignment 1 and assignment 2 is due on the 12th. right? So I give extension. So this is going to be the final extension on the 12th of June. So please upload your assignment uh, by the 12th of June. So basically end of this week. So I'm not going to give another extensions for that, right? Okay, any questions with regards to midterm tests, final exam, and also the assignment? Right. The other thing is basically I think in the past two sessions, the attendance based on who's answering the quiz is quite low. It's only 26%, 26 students doing that. So make sure that you attempt the quiz. Right? Okay, so let's move on to the today's chapter that we need to cover is on Thixoforming process, which is a semi-solid metal process, one of the semi-solid metal processing techniques. Okay, so this the outline of the lecture that we're going to cover today. It's quite a bit. Any questions? No. Okay, make sure that I saw here attendance is 21, only 20 students so far. So make sure that the pass down that I gave you guys on the midterm final exams and also assignment, make sure that you convey that to your friends who has not attending this class. Right? If I have time towards the end of the sessions, then I'll stress it again. Okay. What is Thixoforming? So Thixoforming is a semi-solid metal processing technique. Meaning that semi-solid process means that the process shape materials is being done during at its semi-solid state, semi-solid state, and the operation temperature is at the temperature between the solidus and liquidus. So if you look at this phase diagram, so you know this is there is a depending on so on the x-axis will be percentage of element, and on the y-axis will be a temperature, right? So basically, the operating temperature is between the liquidus and solidus temperature. So basically, this between this temperature and this temperature. So whatever that's in that particular red zone. Okay? So this is a typical phase diagram. So the processing of these particular materials at the initial state of the material to be processed is at the liquidus and solidus phase. Ideally, the slurry should be approximately 30 to 50% liquid. So based on this phase diagram, so where you want to operate at what temperature, it should be approximately 30 to 50% liquid. So you have to make sure that we can have a material that can be in a semi-solid state, and which can achieve that 30 to 50% liquid state, and still in the form that can be handled. That can be handled. Okay. So again, introductions. So if you look at the what do you call it? At the liquidus temperature, at the temperature scale. So see, this is the axis. This is liquidus temperature. So this is solidus temperature. So over here, below here is basically is a solid state. So this is where the two phases exist, both in the solid and liquid state. And above this temperature, basically you are in the liquid state, right? So and we just want to look at the two operation, which is basically over here. So casting done at the liquid state. So the initial material properties of casting is basically liquid. So in order for you to do casting, you have to melt the alloy. Let's say for example aluminum, you have to melt the aluminum alloy, and basically from the liquid state of that aluminum alloy, then you pour it or you use a casting technique, either high pressure casting, die casting, sand casting, so on and so forth. So that's happened here, right? Above the liquidus temperature. So semi-solid, real casting, forming happen here at the semi-solid state. But Thixo and Rio is two different techniques, right? So this is a semi-solid metal casting and forming operations. Right? I'm going to explain a bit the difference between Thixo and also Rio forming later on, if I'm not mistaken. But basically, what happened is for the real forming stage, for real forming process, the conversions of the materials is happening from liquid to semi-solid, and from the semi-solid, you do casting process. You perform the casting process. So that's a real casting process. But for the Thixoforming, either casting or Thixo forging, so the material start from molten state, right? And it casts into a pellet at this stage into solid, right? So there'll be a conversion of material from liquid to solid, and then it's being heated up to semi-solid state above the solidus temperature before we go through the either casting or forming operation. So those are the fundamental difference between Thixoforming and also real casting. Thixo, you have to go into the solid state, preheat it into semi-state, and then do casting. For the real, basically, you're going to have it from liquid state to semi-solid state, and then casting or forming. The idea is basically to achieve these globular structure formations rather than dendritic structure formations. Right? Uh, Operations that happening below the solidus temperature at the solid stage is, for example, cold forming and hot forming forging operations. Right? So that's basically where the Thixo forming uh, comes in, and in what phases of uh, material transformation it goes through, right? And the difference between Thixo forming, real forming, hot forming, and cold forming. Right? So any questions? So if you have any question, just stop me or write something or use chat functions to ask questions. Okay. Okay. So why is semi-solid? So so semi-solid material processing combines advantage of casting liquid and forming solid process. Basically, because of that, then basically, if you process material at the semi-solid state, then there's advantage in terms of microstructure and also temperature at which we have to operate. So the microstructure of the semi-solid alloy is dendritic, consisting a spherical solid phase suspended in the liquid phase before and during forming. So in terms of the advantages in terms of microstructure, so if you look at this, so you have a spheroidal solid state and liquid, which maintain in this way during the solid phase and also during forming stage. So basically, you don't have dendritic structure. So this structure is much better in terms of material characteristics, in terms of strength, so on and so forth, than the dendritic structure. So let's look at the Thixotrophy. What is a Thixotrophy which related to Thixoforming and Thixocasting? Okay. So Thixotrophic means that viscosity of a semi-solid slurry is both time and shear rate dependent. Okay. So what does it mean? It means that the viscosity decreases with increasing shear rate. At constant shear rate, the viscosity decreased with increasing time. So what it says is this: the the thixotrophic slurry is a state of material at which the viscosity state decrease with increasing shear rate. Means that if you have that material if you have a thixotrophic material, a slurry, right? Whenever if you don't apply a shear stress on it, right? So if it doesn't shear, you just put it there, then it will maintain its structure, right? If you apply shear on the material, then it will flow like a fluid, right? For example, simple example I can think of is like a toothpaste or butter, right? With toothpaste, if you squeeze it before you, if you put it on the table, right? Basically, it will just maintain its shape, right? But if you apply a shear stress, let's say for example, you use let's say a knife and try to spread it, it will flow. It will flow. So that's what it meant by this. Viscosity decreases with increasing shear rate. So when you apply shear stress on the material, it will flow because the the viscosity decreases. Right? And at a constant shear rate, the viscosity decreases with increasing time. So for materials, right, not for toothpaste, but for metals, if you shear it at the constant shear rate, the viscosity will decrease with increasing time because of a heat transfer. Because of the heat transfer, then actually the semi-solid metals turns into solid. Right? So this pseudoplastic fluid shear thinning at a shear rate as low as 10 to the minus 5 per second. So basically, so these materials, you can have a very low shear rate, and this is very important because whenever you want to do forming operations, you want to have material to have a very low shear rate and also a very low viscosity, um, and this can be achieved by this thixotrophic slurry. And the alloy are stable when there's no shear stress applied. So as I mentioned just now, if there is no force, there's no shear force acting on that particular materials, then basically it's going to maintain its form. So handling of material would be very easy compared to liquid, right? So for example, just imagine if you want to do what do you call it? The casting, regular casting operations, you have to melt the materials. So you have to handle molten materials. Right? So you can only scoop it and pour it, something like that. So you cannot hold it. You cannot have a gripper arm grip it. Right? But if it's in the semi-solid state, either if it's in the thixotrophic slurry state, then you actually can handle it with let's say gripper arms. So if it's in the pellet form, then you can have a robotic arm to grip it and move it around. Right? So that's the beauty of it. What's a shearing? So this is just explain what's a shearing. I mean, I think this is common knowledge. So whenever you have a shear, then you actually break down the materials into a small functions, and this is a very important what do you call it? Very important characteristic of materials that enable Thixo material slurry being formed using like 4 operations, which we're going to discuss later on. Yeah. So this is a rheological behavior of materials. So if you look at this curve, so in the y-axis is yield stress. On the x-axis is a fraction of solid. Right? So the slurry was solidified to a given fraction solid before shearing. Shear stress increased rapidly after 0.2, 0.15 fraction solid due to dendritic structure. So if you take a look a liquid metal, you pour it in the mold, right? You let it cool. The structure that we form is basically a dendritic structure like this. And for dendritic structure, if you have a fraction of solid above 0.15, then basically shear stress is going to increase rapidly, as shown here, right? So so this kind of behavior of a standard materials that's being solidified during casting cannot be used in the Thixoforming operations. So we have to do something about the materials to modify it such that it will not have this dendritic structure. So we're going to look into how to form a pellet without having dendritic structure. So this is a structural evolutions during cooling. So usually, so if you, as I mentioned just now, if you pour a metal into a mold, then this what happen in terms of the structure formations. First, initially you have initial dendritic fragment, and then it will grow, and then it will turn into rosette form, and then ripened rosette formed, and then spherical form. So we want this form. We want spheroid forms structure in the Thixoforming operations, right? Because if you have this dendritic structure, then basically this will happen. This will happen, once you achieve more than 0.15% of a fraction of solid, then 15% of solid, then basically the shear stress will increase rapidly. Okay? Any questions? All right. This is talking about the three different processes that we have in the real casting, Thixo casting, and Thixoforming. So I'm going to explain a bit so that you are clear in terms of what does it mean by real casting and also Thixo casting and Thixoforming. So as I mentioned just now, for the real casting, basically the initial material being used during the casting process is at the semi-solid state in that phase. So from the solid, from the what do you call it, from the molten metals, is being melted. So you do something to this molten metal so that it will transform itself from the dendritic structure to the spheroid structure. Okay? So once you have it in the spheroid structure and semi-solid state, for real casting, then you cast it. Right? You put and you make a casting. But for if you want to form a Thixo Thixo slurry material, then basically you solidified it in terms of a billet. right? But this billet will no longer have a dendritic structure. It will have a spherical grains structure. Same with this. So, so once you have create this, then basically you have the Thixo material structure. Then you can have two operations. Basically, you can do casting. We call it Thixo casting, or you can actually, this is forging. You can do Thixo forging, but sometimes they call it Thixoforming operation. Right? So once you have that, you have a billet, then basically before you do casting, you have to reheat it. So during this reheating, then basically you're going to transform the solid into semi-solid state and then casting. If you want to do forming, you transform into semi-solid state and then do forming process. So basically, these are the three main routes for the semi-solid metal processing. You can either Rio casting, Thixo casting, or Thixo forming operation. So let's look at the characteristic of Thixoforming forming characteristic. So Thixoforming is a near net shape forming. So just like casting process is near net shape forming process from a partially melted non-dendritic alloy. So you have to remember that the alloy, the material must be non-dendritic alloy, must be spherical alloy. There are three independent sections to it. So there are three processes for this Thixoforming. The first process is in the raw material productions. How do you make that billet? How do you make this? So that's the first operation. How do you make this? Second stage is basically on the reheating, and the third one is actual forming process. So if you look at this, so if you want to do Thixoforming process or Thixo casting process, first, how do you, is the process of making this billet. Second stage is you actually reheat that billet. Third stage is doing the operation itself. Okay, so there are three steps altogether. So we're going to go through these three steps. So it says here, raw material productions. During the aim of the raw material productions, basically, after reheating it to a semi-solid processing temperature, the globular solid phase structure will be obtained. So basically, during reheating process, you're not going to get dendritic, but you're going to get a globular static phase, solid phase. And the characteristic structure is generated by shearing the liquid alloy during solidification, either mechanically or magnetically. Right? During using these two processes, then dendritic structure are globalized. So basically, during the productions of the raw materials of that billet, to convert the material from the dendritic into the globalized structure. So from here, if you melt it, if you melt it and solidify it using regular casting, you're going to get dendritic structure. Right? So how do you get these spherical grains or globular structure? Then basically during this particular process, you have options either to use mechanical means or electromagnetic means of converting the dendritic structure into a globular or spherical structure. After the total solidification, structure will retain during reheating. And if you achieve this, right, then when you reheat the billet again before the forming operation, then basically you're going to retain spherical structure. Okay, any questions? So this is Thixoforming characteristics or stages. First, you have to produce the raw material production itself. You can do this by two means. One is mechanical stirring. The other one is magneto-hydrodynamic stirring. So this is a fancy word, uh, if you look at, let's say, for example, in the lab, right? So in the lab, sometimes you saw people put a beaker contain the liquid on one apparatus, right? And by push a button, basically you can see the fluid inside that beaker stirred, right? So that's being done using this magneto-hydrodynamic stirring. Mechanical stirring is basically you stir it mechanically or you let it flow mechanically. We're going to go through this process. So again, the three steps in the process. One is raw material production. Second is reheating. Third is the forming itself, either Thixo casting or Thixo forging process. So this is how this is talking about the discussion about making the billet. How do you make how this first stage is being done? Billets are cast from semi-solid liquid processing the real cast non-dendritic microstructure. So during Thixoforming, you have to use billet, and this billet are cast from the semi-solid fluid processing the real cast dendritic structure. The billet itself could be heated at a later time uh, 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 to a semi-solid temperature range. So you have to heat it up above the solidus line, but below the liquidus line. Below the liquidus line. So the objective of feedstock productions is basically you want to manufacture or you want to make a non-dendritic or globular primary phase with a fine grain size uh, uh, in uniform, which is uniformly distributed in a matrix of lower melting point. So the objective of the feedstock production is you want to make a non-dendritic or globular or spherical structure material with a fine grain size. So you want to have non-dendritic and fine grain size. So those are the two objectives. Questions. Bila reheating process tu ada effect tak karakteristik of materials tu dengan effect pada finishing? Ada effect kalau reheating is not done properly. So during the reheating process, there's methods on how to do the reheating. We're going to cover that later on. We're going to cover that later on. So kalau reheating process is not done properly, then you can have you can change the characteristic of the raw materials. Okay. I hope that answered questions. But we're going to go through that later on that. So the let me just put this on the side. Okay. So the raw material in the solid state for the subsequent reheating into a semi-solid state and component shaping through the Thixoforming. So once you make this billet, it will go into a solid state. So it will go into a solid state. Then you have to reheat it before you go through the forming process. Thixotrophic feedstock production can start either from liquid alloy through controlled solidification under specific condition or from the solid state through heavy plastic deformation and recrystallization. So the thixotrophic feed stock productions can start from either liquid alloy or solid state. So we're going to go through the process on how this is being done. The transformations of the dendritic structure can be done at the liquid state or at the solid state. So if it's done during the solid state, it will go through heavy plastic deformations and then recrystallizations stage. But not all alloys can be used for this particular purpose. Only selected alloy. We're going to and in aluminium I think there are two commonly used alloy that being used for this. Right? The mechanical properties offered by Thixoform cast alloy may not be sufficient for specific application when higher strength, especially high fatigue strength, is required. So basically, what it says is here. So when you make the billet, when you make the billet, you can use the billet as it is, but the billet as it is, without going through the casting, without going through the Thixoforming operations, will not have a high strength and high fatigue strength. So you can use it, you make a billet and you can machine it, but it doesn't have the strength and also the fatigue strength that's required in many applications. So because of that, then you have the Thixo material that's formed must go through that forming process for it to increase its strength and also or other properties. Rough alloy are very difficult to cast or shape in the semi-solid state owing to a very strong temperature dependence of the liquid volume fractions. So basically it says here, most alloy is very hard to cast or shape in the semi-solid state because of the strong temperature dependence. So because of that, then only limited